Hello there, welcome back to Petrophysics Rocks. It's been a while since my last update, longer than usual. I'm trying out a new YouTube technique where you don't release a video for a couple of months and then come back and see how many subscribers you've got left. It's at the cutting edge of the algorithm technology. I think we're nearly up to 800 subscribers now, so maybe we'll get to the 1,000 by the end of the year. Things have been busy on the home front here. I've been in New Zealand for a month in January, and then I was away for a short while in Spain, and went down to visit the various sons in various places, for various birthdays down south. So I've been busy, but I have been busy on my favourite, current favourite, Petrophysical Maker Suite, GDPC Petrophysical Maker Suite. I've done a couple of videos promising, but not delivering so far. In this video, I explain some excuses as to why it's taken me so long and the efforts that I've made to try and catch up. But mainly, I thought it was worthwhile giving you an update of where I got to with trying to put some real geology, in inverted commas, into the EARTHmaker portion of the GDPCmaker suite. You'll see that before I've introduced it, I've talked about random noise and stochastic noise and shuffling the beds around. But what I've been trying to do over the last couple of months is put some real geology, some bed form shapes in a way that other creative people can create some realistic geology, or more realistic geology, with this EARTHmaker log. Anyway, please like and subscribe if you can, and comment down below. That might help make up for my last couple of months' absence. I do apologise for the length of time it's taken me to get there, but as a retired guy, I guess that's the thing I've learned about AI, really. I think only us retired folk have time for AI. Obviously, if I was trying to do this commercially, I wouldn't get very far, I don't think. But the nice thing about AI is that you can and being retired, is that you can take your time and delve into it a little bit more and push it a little bit harder and make sure you get what you want at the end of the day. And so I'm just trying to build this suite together, and hopefully you can see some progress in this update, and hopefully it won't be as long next time for the next update. Okay, so without further ado, let's get on with the Petrophysical Maker Suite. Hello there, welcome back. This update to the GDPC Petrophysical Maker Suite. I thought it worthwhile giving an update in case you're wondering how I was getting on with it. This one's back on EARTHmaker again, which I've introduced on the channel before. EARTHmaker is where we put this synthetic geology together, build a geological earth model, then we take that data, and I've introduced a thing called Core Maker now, where we'll take core in that earth model, bring it back to surface conditions, and core relaxes, and all of the parameters are not necessarily representative of downhole conditions anymore. And in that process, we'll learn how to make overburden corrections and put it back to reservoir conditions. Then we'll calibrate. Then we'll also use LogMaker, which is the third sheet in the suite. We'll use LogMaker to record some synthetic logs over our EARTHmaker geological model. At some point, I'm probably going to introduce a high resolution earth model, maybe, I don't know, 1 inch or maybe 1 centimeter earth model, create the earth properties, and then we'll log our traditional half-foot logs over it. I've got some real physics in there now, and we'll create a set of logs that you would encounter if you got to ever log our earth model. And then we'll go into CPImaker, and we'll pick up the core that we've taken from our earth model. We'll pick up the logs that we've made over our earth model, and we'll learn how to analyze logs in general. The idea behind this was originally just to give us a petrophysics training course, and when you don't have data of your own, or when you don't have data that's released data, sometimes it can be a bit tricky. But here I thought the idea is that we'll make our own Earth model, and we'll give it to 8 or 12 students, and we'll go through this process, analyze the logs, and then compare back to the Earth model to see what our results are like, and can we get back to Earth model results with our traditional core and log analysis process. Once we've done that, we'll, just for grins, we'll put it into the FlowMaker log, and we'll predict some flow rates, both oil and gas rates, and we'll see what flowing the logs gives us, and also we'll go back and we'll try and flow the Earth model as well, so supposed reality, and then we'll see how that compares to our final analysis of our log data set. Anyway, it's been taking me a while to get through this. It's the joy of being retired, I guess. I don't have particular deadlines apart from my ever-eager YouTube audience to see how I get on. But I thought we'd revisit EARTHmaker. I know it's a second time around, but as I say, I'll put a bit more geology into it this time, so hopefully you'll eventually appreciate that when you get it. And the whole idea of this is that I'm going to put this package together and then distribute it kind of freely to you, if in exchange for a contribution to the Aberdeen Royal Children's Hospital Archie Foundation, and you send me a screenshot of your contribution. I haven't decided the exact pricing structure yet, but it'll be, you send me a screen dump of your contribution to my Archie Just Giving page, and then I'll send you this suite of logs. I'll try and make them a bit modular, so you can buy one for a contribution, and then if you buy 2 or 3, then I'll give you a discount on the third one, and things like that. So haven't quite decided the commercial model yet, but that's the overall idea anyway. Okay, so where are we now at the moment? So EARTHmaker, the first spreadsheet in our suite. This update is, as I say, more geology. I've introduced this before. This is an overview of all of the different modules there. You can pause this and have a read. This is the idea of what each of the spreadsheets do in the suite. And if you find it useful, as I say, there's a contribution to the Archie Foundation would be appreciated. Okay, so we're going to talk about EARTHmaker, building these Earth models, and this is the cover sheet for EARTHmaker. You got a little bit of guidance here, and some description of where all the data is and how it's all laid out and where you can find things, which I'll probably update later when I've finalized everything. I'll probably do an introduction again to the structure of the spreadsheet. But here you'll see also that we're reporting reservoir sums and averages from our Earth model. And this updates in real time. So this is the gross interval, sand, net interval. And I've decided I'll just do 3 zones, basically, perforation zones. I'll treat them as perforations, where I'll show you where you can select the inputs that you want to perforate, and then these tables will populate, and you'll get an average, a gross, net, sand, net to gross, pay, hydrocarbon pore volume, and then you can select the logs that you want to average over. So here I'm averaging the average V clay, phi T, phi E, for those who like that sort of thing, and SWT and a permeability. I haven't populated the flow rates as yet, because I haven't brought my FlowMaker code back into the Earth model yet, but this is the EARTHmaker cover sheet. And the first section you'll find in EARTHmaker is the structural modeling approach. So here I've got where you build the models. So I've got a Fasces distribution, but more importantly probably is the layer inputs. You choose the number of the number of layers that you want to build, the number of beds, and it puts them into this shaly background. So in this case I've got 3 beds, a sand, Aeolian sand, a couple of fluvial sands in a shale background. And here is the table. I've input here that I wanted to start out. I've input the average bed thickness of my Fasces 1. The Aeolian is 75 foot, and the average thickness of my fluvial, my sand A. In essence, this is good sand, bad sand. So I will adapt this At the moment, I've just got two sand fascies in. I find that tends to be the case. You can make the case for a good sand and bad sand in most reservoirs, I think, and you can put in the statistics of those sands, and then this realization will give you an attempt. One realization will give you an attempt to get there. So here, the average aeolian sand thickness in achieved is 80 foot, and the average fluvial is 18 foot. From a target, I said I wanted 75 and 20. It's done that. So I can run various realizations of it, and again, you see you can check the averages that you're achieving here. So how close to your original input do you want? And it's a three bed model. You can have various distributions. I've got here a probability of fascies 2. The fluvial is increasing, so it's more likely that the fluvial sands will be in the bottom, but really there's still possibilities for other configurations as well. So what I can do is I run various distributions of sand and fascies, and it reports the results here. And here's where I select I want to perforate layers 1, 2, and 3, and then that will go back to the sums and averages table on the cover and calculate the average properties. And I'll show you how I get to properties in a minute. So at the moment there's just 3 beds, but you can add more beds than that. So here let's add 6 beds, and let's go full bifter, 10 beds. The equations all spill, so however many you put in, it will accommodate that. For display purposes, I've just limited it to 10, and you can see again the probability of fascies 2, the aeolian. More of these lower beds are realizing the fluvial fascies, and I can get various realizations. This is mainly all aeolian. It's a bit random, I guess, and so what I want to do is I want to if I want to make sure that I get some aeolian fascies in, I can manipulate this curve, and I can put a bit more higher probability of fluvial fascies occurring at the top. So you can manipulate this table by putting in, it has a background trend, which it starts off with, and I can just put in sort of local maxima and control the window width and try and influence the stats. But I can build various realizations. But when I first started this, I didn't have that ability to do that, so I've just added that recently. So this is the one that I've done most work on. And what I do is when I've seen a configuration I basically freeze the structure, press the camera, and then that locks in that bed geometry. And then I take those beds and I take them into this intra-bed morphology working. So here I'm going to create the properties of the beds, if you like, mainly through, this is the V shale section. So I'm building the bed geometries, the morphologies. Here I've gone back to 4 beds just to show you how that impacts things. So I can do a number of beds. I can do 6, or back to the 10 that we had just here. We had 10 here. I'm just showing you that these beds change, and here we are, the full 10 bed geology that I'm trying to create. And so here this is a V clay property, and this is a V shale property. Now we can have a debate what the difference between V clay and V shale is. Generally speaking, V clay is the background clay mineral, if you like, the mineral content of clay, and the V shale, I think of it as more of a sort of a bucket term, but it often is taken to be a combination of clay and silt, and that's the assumption that I've made for ease of calculation. So the V shale includes a silt fraction, and so the V clay is the grey curve here, and the V shale is the brown curve here. And what I want to do is, this is just using average properties. So I've said that my shales are 70% clay and 95% silt or whatever. So altogether they come up with 95%. So those are constant values. What I want to do is I want to use a depth trend. So I apply a depth trend. So we're just using a depth trend now, and then I want to use separate properties for each bed. So I switch on what I call intra-bed properties. So here, each bed, this is the same trend throughout all the shales, and here I'm using different trends for each bed, basically. And what I've done here is I said I'm going to use a concave shape for my sands, for my V-clay minimum, and I'm going to use a linear coarsening up trend for my clays here, and I'm also going to use the same. So I'm using the same thing here. I'm using concave sands, if you like, these curves here, and linear shales, which all coarsen up. So you can see this difference here if I introduce if I toggle between the properties in the depth trend. And then I want to sort of, well, actually, I don't quite like that. Let's do something different. Let's introduce different morphology. So here, I'm going to keep these concave sands, and I'm going to keep the linear shape. I'm going to make the clay blocky. So instead of having a fining up trend, I'm going to make the clay blocky. I'm going to keep the shales fining up. Coarsening up. Freudian slip, and then I've introduced this sigmoidal shape, which is kind of like a fining up here. So each bed has this sort of like little kink in it, this little sigmoidal shape in the middle of it, and that's all a bit too regular. If you look at it, it doesn't look particularly geological. So I want to sort of vary these properties a little bit. So I have some uncertainty about these shapes here. So I sort of say, well, okay, the degree, the sharpness, the degree of curvature I'm uncertain about. So I'm going to give that a wide range. It's just a model after all. So, and then I'm going to say, okay, there's a 15% uncertainty on the amplification. The amplification is like the difference between the minimum and the maximum within a bed. So it's I'm going to let that vary by 15. So here I've got some randomness in the intra-bed properties. Okay, so I let this, if I run a few realizations, I can see that things varying a little bit, so that it's not all the same shape. Here I've got a good sigmoid, and in this particular case I've got a difference that, as I say, the V shale is fining up, but the clay is staying relatively constant. Okay, so I've run some various realizations there, but it still looks a little bit boxy and unrealistic. So what I want to introduce is a sort of an intra-bed shift. Let's just sort of move these things around a little bit. So what I've done is I've said I'm adding a zero mean shift. So if I toggle between these two, these shapes are all on trend, but let's just introduce a bit of variation, and you can control how much you put in. I put 5% variation in on the clays and 10% uncertainty variation, if you like, in the shales. And you can see now that they're starting to sort of move around independently, but they're still on the same trend. So if ever you attend one of my courses, you'll know that actually that I'm cheating, because the trend will always add up, and this is just adding noise either side of the mean. So I can run various sort of simulations of that, and you can see things are varying. And then the idea will be, when I find one that I like, I will freeze that. I will freeze that a little bit. But you'll also notice that if I go back to here, these properties, if I toggle through this bed here is pretty much always sigmoid around the same place. There's a fair bit of uniformity in their sort of stuff. So what I've done here is I've just shuffled the beds. I've allowed this bed to sometimes take on the properties of that bed, and vice versa. So this gives it a bit more variation in the geo noise, if you like, or sorry, in the bed shifts, and then so I've got various things moving around now independently, so each bed can shuffle properties between each other, sort of stuff, and then I introduce a bit of geological noise. So this is where we're starting to get a little bit more loggy-like sort of stuff. So I've introduced the geological noise, which I've defined, which I've explained to you guys before, I think, on the channel. But as I say, I wanted to introduce a little bit more realistic geology, or some ability to create realistic geology. So those with a creative mind will do that quite well. So, and the geological model, kind of the geological noise shifts around, and you create various realizations, and that looks reasonable, and you can play around with it. I still have a little bit of problem with the noise, which I'll discuss in a minute, but various realizations and snapshots, and when you're happy with one, you can freeze it and export it to your class and give them these logs to analyze. But if we go back to some thicker beds, if you like, what does it look like on a thicker bed scenario? So here I've gone back to the 3-bed scenario, and here I've got a very large, thick bed, which I know is Aeolian, and a couple of fluvial beds here. I didn't put the fascies shading on this. I'll add that next time. And again, you do various realizations. The structure is now not frozen. I released the structure. All of these ones were done on the same locked structure, you see. So you can see that there's 10 beds, and they pretty much stay where they are all the time, and you're just wobbling various things. It makes it a bit easier to evaluate the impact of various morphological changes. And then when we go to the 3rd bed again, I've unlocked the structure, and I've allowed the structure to vary, so the layers vary. So here's 2 thick sands and a little one, and then there's various configurations of sand. And I guess one of the things that I think I'm missing here on these thick sands is I think I need to introduce a shape, a cyclic shape. So this is just one concave sand from top to bottom, and this is one sigmoidal sand here. So I get various nice looking geological features, but I think I probably need to introduce a cyclic thing. I'll probably control the frequency. I'll say, okay, not going to full shales, but just introducing a little bit of more intra-bed homogeneity. When I've got these large beds, I think I could afford to introduce a little bit more cyclicity in there, because obviously geology is often cyclical, and whilst it may not develop into full shales, I think I'd quite like to be able to introduce that as a tool. And perhaps also the noise is just a little bit too random and not geologically bedding-y enough, as it were, whatever the technical term for bedding is. It's a bit too random to my eye, so I think I might tweak the fine scale geonoise, and I might introduce a bit more cyclicity in the bed morphology. So that's as far as I have got to with EARTHmaker so far. As I say, I've got a couple more tweaks to make, which will delay it a little bit further, and then we'll take those models into CoreMaker, and we'll extract some properties from the Earth model and bring them back to surface and have them relax, and we'll do some special core analysis on it, and we'll see what we can overcome with. So basically, what I'm saying here in a little summary at the end here is that the input that you need is a questioning mind, some imagination, and a problem to solve. If you've got a problem, you think, well, what would that be in reality? Is my sand really being invaded by mud filtrate so much? What would that look like? What effect would I expect to see if I had 30% mud invasion or a little bit of washout in the whole? How would that affect the logs? oh yeah, that's the right sort of order of magnitude. So I'm kind of want to introduce it as a sort of a QC check for your real world problems. If you have somebody telling you that, yeah, these logs are all fine and that's what you'd expect to happen, you can play in the sandbox, as it were, and sort of say, yeah, that's the sort of order of magnitude effect I'd expect to see. So this is where I'm up to so far. And as I say, if and when you fancy giving this a go, when I release it, or release various modules of it, then all I'll request is a contribution to the Aberdeen Royal Infirmary Children's Hospital, the Archie Fund, which is linked in the link down below in the description to this video. So you could give me a precursor down payment, if you like, if you trust me. Just a fiver or a tenner would be good as a sign of goodwill. As I say, when I've got this stuff together, I'll probably come up with some more commercial terms. It won't be a great deal of money, but something to show willing, I think, and try and raise a bit of money for the Children's Hospital. I'm sure they'd appreciate it. Okay. Well, thanks a lot for your attention, and hopefully next time, the next update will maybe be on CoreMaker, maybe close out the EARTHmaker stuff where we got to then, and then we'll take the CoreMaker and see what core properties we can derive from it. Okay, thanks a lot. See you next time. Cheers.